Hello and welcome to another episode of Late Night Code. So I know we're late night code, but I found an opportunity to do recording in the middle of the day, and I'm taking it because I'm really excited to get into more problems and I want to be able to share them with you. So we're taking every opportunity we can get. This problem is called Blueberry Waffle. It's another problem from the Southeast Regional 2022 contest in ICPC. This one's actually part of Division 2. Now, the problem we worked on last time was fading wind. It was the easiest problem in the contest at a 1.4 rating on Caddis out of 10. It was included in both Div 1 and Div 2. Now, Blueberry Waffle is a 1.5 rating, so just slightly more difficult, and it was included in the Div 2 contest. But again, I want to solve them all, so we might as well start with the easiest ones and work our way up. So let's talk about the problem. Blueberry Waffle. You are using a waffle maker machine to make a delicious blueberry waffle. One side of your waffle is covered in blueberries while the other side is plain. Initially, the cooking pan of the waffle maker lies horizontally and the blueberries are on the top side of the waffle. Once started, the cooking pan will rotate at a constant speed for a fixed duration, then stop. The cooking time is set so that when the waffle maker stops, the cooking pan will not be in a vertical position. If the cooking pan is not horizontal after this time, the waffle maker will return to a horizontal position via the smallest rotation possible. Therefore, the waffle maker will rotate less than 90 degrees, either forward or backward, until the cooking pan is horizontal again. The pan rotates at a rate of 180 degrees every R seconds and stops after F seconds. You don't want to take out your waffle with the blueberry side down, therefore you'd like to figure out whether the blueberry side of the waffle is up or down after the cooking pan returns to a horizontal position. The input will contain two integers on the same line, R and F, where R is the rotation. Every 180 degrees, or every R seconds, it rotates 180 degrees, and it'll stop after F seconds. And then we need to output a single string, which will either be up or down, where it's up if the blueberry side is up and down otherwise. Okay. So let's go and kind of simplify this just a little bit, or summarize, we should say. So basically we have a blueberry waffle. It currently has its blueberry side up and it rotates 180 degrees every R seconds, which is kind of like saying that the blueberry waffle has a parity. It has the upside parity and the downside parity, and it changes parity from up to down or down to up every R seconds. We're also told that it'll rotate for F seconds, and it might be the case that F is not evenly divisible by R, which means that it would be in between parities. And effectively what happens then is if it's in between parities, it has to pick one based on the smallest rotation. So the way to think about this is if it's currently up and it rotates 45 degrees, then it takes 45 degrees to move to the up position, or 135 degrees to move to the down position. So it's going to take the up position. But if it's 135 degrees after being up, then it will be 45 to the down and 135 to the up. So we'll take 45 to the down parity. Okay. So this is effectively what we're working with. And they told us that it'll never be perfectly vertical. Okay. So for this episode, what I want to do is work in a ScalaDraw. A ScalaDraw is an online whiteboarding and collaboration tool. It is really great. And there are whiteboarding tools that have more features than ScalaDraw, like Krita, which you can install. But I find that ScalaDraw has exactly what I need to get stuff done, and that's honestly really awesome. So let's go ahead and set up a basic example of what we're working with here. I'm going to go ahead and create for us a blueberry waffle. So there's our waffle, and we'll go ahead and add some blueberries to it. And then I'm going to go ahead and select this. Oh, that was weird. Pretty cool though. Let me drag this back up. Let me go ahead and put this on my clipboard. And then the next thing I want to go ahead and do now is set up my rotational axis as my example. So here's my rotational axis, and this can rotate a full 180 degrees. And if it were to rotate the full 180 degrees, then the consequence of that rotation would be that we'd get a blueberry that is now on its down parity. So this is down and the other parity is up. Okay. And this would be the case that we've rotated a full 180 degrees. So now the cases we're working with here are going to be relative to its vertical axis. So we're going to have a situation, for example, where we have a blueberry waffle and it's rotated, let's say 45 degrees. Okay. So now we ask the question, if it's rotated 45 degrees, what is the consequence of that rotation? And the consequence of that rotation should be, let me go ahead and select this blueberry waffle here. The consequence of that rotation should be that it now returns to 0 degrees of rotation. Since it starts in the up position. So effectively it doesn't change parity, and this would be true if it was in the down parity as well. Then the other case that we'd have to work with here is going to be the case where we have a blueberry waffle Let's see if I can grab it. Sometimes my keyboard does not want to do a Control-CV. There we go. So we have one where it's now rotated not 145, or sorry, not 45 degrees, but 100 and, oop, that was the line tool, 135 degrees of rotation. So now if we have this 135 degrees of rotation, what should the consequence be? And the consequence should be that our blueberry is now in this down position. So we can drag this over to here, and we'll go ahead now and fill in the rest of this. So this is 180 degrees, okay? And this, let's see, let's go ahead and grab right here on the upside. And so this is currently up, this is currently up, this is currently up. So this is what we're working with in terms of our examples. Now, what's a better way that we can abstract over these examples? So let's go ahead and pull these guys up. And the way that we can kind of think about this for just a second is to basically say that we have some setup for our axis. So this is our vertical axis. So this is our vert. And then the way that our rotation can happen is that our rotation can happen anywhere along this half circle, where if we're somewhere on the left half of this half circle, right, this is the no change. So this is the no change. I cannot spell with Excalibur apparently. So this is the no change. And then the right-hand side is the change, okay? Which means that everything on the right-hand side goes to the next parity, and everything on the left-hand side goes to the bottom parity. Okay. Now, we can further describe what's happening here by jumping a little bit more into mathematics. So earlier I said something like f may not be evenly divisible by r, right? That's possible. Well, we have a way to describe that in terms of mathematics. So we can come over here and we can talk about the value of f with relationship to r. And the value of f with relation to r is going to be f is equal to now dr plus k. And what this formula basically means is that f is equal to some coefficient multiplied by r plus some remainder after division, where d is greater than or equal to 0, and 0 is less than or equal to k, which is less than r. These are the things that we're working with, okay? And there's a really good way, an easy way to calculate k, for example, and d. D is going to be the floor of f over r, and k is going to be f mod r, which mod is the remainder after division, which is what k is. So these are effectively the things we're working with. And what we've been told in the problem statement, let me go ahead and kind of leave that there. What we've been told in our problem statement is that it is the case that r is equivalent to 180 degrees of rotation per second, is the way that you can think about that, okay? So then now, if we think about r is 180 degrees of rotation per second, or change in parity, then d here now represents the number of times we change parity, okay? So d is the number of times we change parity. We start with the parity of up, and so if d is 1, we change to the down parity. If it's 2, we change to the up parity. And so another way that we can think about that to go a little bit further is to say that now if d mod 2, or to get a little bit better math, a little bit, let's not go into mod real quick. Let's just describe this a little bit more in English. We can say if d is even, okay, then that means we have no change, which is also the same as saying that we have the up parity. Because again, to describe this, we start with up. And so if d is 1, we go to down. If d is 2, we go to up. But now we're back in our same position. So every odd increment changes our parity, and every even increment does not. And so if d is even, there's no change to our parity. And if d is odd, then we have a change. And that change means that we're now down. Okay. But then the factor that we have to consider after that is the case where k now plays a role in this calculation, okay? And so how would k play a role here? Well, K, again, is going to be between 0 and R, where R represents 180. And it would need to be the case that K is less than 90 degrees, which we don't really know what the degrees are, but we do know that if R is equal to 180, then R over 2 is equal to 90 degrees per second. So now we can ask a very simple question, which is how does K, right? How does K compare to R over 2, right? How does it compare to R over 2? Is it less than equal to R over 2? Is it greater than R over 2? And that tells us how to affect our parities. And so now if we were to go down here and fully describe our parity, then we can frame our parity kind of like this. And actually, do I have a little bit more space on the right-hand side over here? I do. So let's go ahead and kind of frame our parity like this. Okay. Oop. We can say now that if we were to describe a function that's like the parity of our waffle, okay, the parity of our waffle, given in this particular case, F and R, then what we can do is now describe that parity as being either up or down, okay, based on whether or not D is even or odd, okay, where D is equal to F over R, okay. So now we'll come over here. So D is F over R, floor of, okay. And we want to know if this is even or odd. So then we would say mod 2 equals 0 for even. And then this one is the otherwise case. Otherwise case. Okay. But then there's one other thing we have to consider, which is how does K add to this? Okay. So how does K add to this? And so then now we would need to consider plus K. Okay. Where the K here is now going to be its own function, where K is equal to 1 if K is greater than R over 2, or 0 otherwise. Okay. Does it kind of make sense? So again, the parity of our waffle is up if it is the case that F over R, okay, so the number of times it rotates, plus this K factor is even, where the K factor means that we add 1 if it should move to the next parity, or 0 if it shouldn't. And if that's even, then we've moved back to our same position. If it's not even, then we've actually moved to the other position and we're now down. So this is effectively how we can think about our solution. I hope that this was a little bit helpful. I will continue to work on my Scala draw skills, but let's go ahead and talk about how we can actually code this up. So let's jump over here into zellij. I've already got zellij set up for Blueberry Waffle, and I'm going to go ahead and open up a NUPHY session here and go over to mod. And then inside of mod, I'm going to say pub mod blueberry waffle for our Blueberry Waffle solution. And then we'll come down here and we're going to say Blueberry Waffle is going to be mapped to ICPC SE Reg 22 Blueberry Waffle main. Okay, and then we'll open up my Explorer, and then we're going to copy hello into source solutions ICPC SE Reg 22 Blueberry Waffle.rs. And then now, 6K. And so now if I open this up, there's the Blueberry Waffle file. That looks great. And then if we come over to a main's looking pretty good as well. And so now we can talk about how we're actually going to solve this Blueberry Waffle. Okay. So the first thing they tell us is that we're going to be given an input where the input here is going to be a single line RNF. And these are immutable. So we'll say let RF be equal to a block. And then in here, we'll say let mute buffer be equal to string new. Then we can say IO standard in to grab that standard in, read line, passing in a mutable reference to the buffer, and then unwrapping the result to go ahead and report any errors. Then we can, the next thing we can do is collect our params, which will be a vec of I32s. And that's going to be equal to buffer and then dot trim, dot split, and then here dot map s and then s dot parse into an I32, and then unwrap that result to get the value out or the error thrown, and then collect them into that vector. And then after we've collected them into the vector, we can just return params at 0 and params at 1. And let's go ahead and make sure that I've got the correct order there, R and F, and they can go up to 10,000. Okay. And so then the last thing I want to be able to do is determine what the value of D should be based on this particular formula. So now what I can do next is I can say let D be equal to, and then D will be equal to F divided by R. Now the other thing that I want to be able to add is this 1 or 0 based on whether or not K is greater than R over 2. So I can actually come back here and I can say if F, and then we'll say in this particular case, greater than R divided by 2. Okay. And so actually, sorry, this is K. We talked about K being the F mod R. My apologies. Okay, there we go. So if K greater than R over 2, and K being here F mod R. So if F mod R is greater than R divided by 2, then that's the case that D is equal to F divided by R plus 1. Otherwise, D is equal to F divided by R. Okay. And so that sets D. And then now we can say if D mod 2 is equal to 0, then we go ahead and print line saying, in this case, up. Otherwise, we print line saying down. Okay. And that will report our solution based on that parity. So then now I'm going to go ahead and do a new floating pane here. I'm going to make that a little bit bigger. And I want to say cargo run dash 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 Blueberry Waffle. Okay. It's going to need a sample input. So let's go and grab a sample input, which will be 10 and 20. And it reports up. So that's already looking pretty good. Let's go to Sir Judging. Let's go ahead and grab that data. So we'll grab the data here. And then we'll go and move that data over. Let's see. So there's our users, our downloads, our data. Paste that in here, unzip the data, and then we're going to go ahead and move that data into tests Blueberry Waffle, and then remove data. And then afterwards, we're going to go ahead and run quest on Blueberry Waffle. And we got eyes down the board. So let's jump over to Blueberry Waffle on Caddis. Okay. And there we go. We've passed 63 out of 63 cases on Caddis and solved our next problem in ICPC. So I hope that you enjoyed this one. I hope that was helpful. Let me know if you liked Excalidraw. I will continue to improve my Excalidraw skills as we go through this. I think it could be a really useful tool. I hope that you're excited for the next episode. I surely am. But until then, have a great night, and I'll see you in the next one.